So no one joined till now. Okay, I'll wait 5 minutes, then I'll start the recording. I'll start the session. Actually, recording is already started. Okay. Okay, now I'll start. So today I'm going to solve the question number that is week number 7, the fluid mechanics, which is about the dimensional analysis. So as you can see here, the dimensional analysis we are going to discuss. So we are going to cover the question from the dimensional homogeneity and the dimensional analysis and similarity. So we are going to focus on these two topics. So before moving ahead, let us discuss about some basic of the dimensions. So here you have the list 1 and list 2. List 1 is about the kinematic, the P is given corresponding to kinematic viscosity and Q is corresponding to force. Similarly, R is surface tension and S is density. So you have to match the correct dimensions. That is the match list 1 and list 2 and select the correct dimensions for the property using the code given below. So code is PQRS and here 1, 2, 3, 4 is given. So as you know, the kinematic viscosity is dynamic. How we will, let us discuss how you will calculate. If someone not know about the direct formulas, like kinematic viscosity have the your direct, if we talk about and force. So let me just derive that is meter square per, or you can see the dynamic viscosity is nothing but the kinematic viscosity is the dynamic viscosity mu divided by rho. This is your kinematic viscosity, which gives the dynamic viscosity is Newton second per meter square, and this is your kg per meter cube. So actually I have not today the pen in my hand, so I am writing with the mouse. So kg per meter cube. So from here you can think and you can write this Newton in mass into acceleration, you know already. So kg meter per second square, right? So here Newton second means 1 second, say 1 second is cancelled. So let me just put it here, just for your simplification I want to write kg meter per second square. This is about the your Newton, then second, then divided by meter square. This is for the mu, again meter square, then divided by kg per meter cube. So this is all. So here 1 second, so 1 second is cancelled out and 1 meter cube, so 1 meter is remaining. So kg and kg is cancelled out, this meter go here, so meter square by second. So meter square by second means what? L to the power 2 and T to the power minus 1. So this goes to m is already, so m means kg. So kg is not here, so m is 0. So you can direct link with that is kinematic viscosity is linked here, this one 4, that is maybe option C or option, this is option D, not A, maybe option C or option D will be correct. So yes, for S 3 is, so for density the 3 will be, that is kg per meter cube. Yes, for surface tension is force per unit length. So force is this one, kg meter per second square, means m l t minus 2, and another you have L, so L will be cancelled out, so M L mt power minus 2, so m t to the power minus 2, and in each option L is present, so L raised to 0, so this is 0, so this will match your surface tension, that is option 2. So option D will be correct here. So hopefully you will understand. If not know anyone, otherwise it is very basic question from 11, from your class 11 you know already the how the dimensional analysis, how the this find out the dimension of any quantity, physical quantity. Okay, so let us move with the, so here you have some primary dimensions, mass symbol is m, length symbol L, time you can look here, and this is temperature, the electric current, and amount of light and amount of matter. This is your primary dimensions which you have the 7. So here is unit is kg, meter for length, second for time, Kelvin for temperature, ampere for electric current, candela for amount of light, and mole for your amount of matter. So this is the basic. Now what is dimensional homogeneity? What we are discussing previously, dimensional homogeneity in one terms you can understand very clearly. Homogeneity means one apple, two apple, and this is not apple. So this, whether this combination is homogeneous? No. Once you will put the apple again here, then it will be the homogeneous. Homogeneous means something should be same things. That is apple, the apple should be there. Meaning, if a quantity have unit meter and another quantity have unit meter, then we can say this is dimensional homogeneous. If someone have some quantity have the meter per second and another quantity have kg meter per second square, so you cannot say this is homogeneous. So I am audible, please just confirm. Hello, you can write in the chat box or you can use your mic also, whether I am audible or not. Hello, I am audible. Is Larson, I am audible. Let me just check using my mobile phone. just. Hello. Hello. Yeah, it's audible. Okay, no issue. So let me just discuss. So this is about the homogeneity. So let me just read. We have all here the old saying, you cannot add the apple and orange. You know why? Because this is not same. This is actually a simplified expression for for more global and fundamental mathematical law of equations, the law of dimensional homogeneity. State as every additive term in an equation must be the same dimensions. Meaning, if you want to add something, let us talk about your equation of Bernoulli equation, P by rho z plus V square by 2z plus z. Why we are adding these terms? Equal to constant. Why we are adding these terms? Because this term have also unit of meter, this term also unit meter, and z also meter. Means you can add something which have the similar unit, similar dimensions. So remember please. Okay, some concept also I have. This is very important. A dimension, a dimension is a measure of physical quantity without numerical values. While a unit is a way to assign a number to the dimension. For example, length is dimension, but centimeter is unit. So remember please. So dimension is a measure of physical quantity without numerical values. So let us suppose length. So the what is the length of your screen? Length of your screen, the remote is your laptop screen or mobile screen also you can say. But for express your in terms of quantitative, how you will tell the quantitatively whether it is how much length and so using the centimeter or meter you can tell about very clearly, yeah, this is this much length. So for example, the length is your dimension and the 3.2 which is the length of this in the centimeter, length of this scale. So remember please, the dimension unit, the difference between the dimension unit is the unit gives idea about the quantitative way. Your dimension is qualitative, but unit gives them quantitative. When you will say something, so like if you want to measure something, so you need to go with the unit system. Remember always. And what is dimensional analysis and similarity? This was your second concept. After that, I'll just move on the questions and answer session. Just for some student, if any student not know about the prototype and model, so I'm just highlighting. So as a prototype means the actual thing. Let us suppose if you want to prepare some building or if you want to construct some building, So you have to understand this is a high story building. Not I am talking about the one story, two story. If you want to go with the high story, 20 story, 30 story. So before constructing your building, you have to understand how much the wind velocity will act, how much the slenderness. If you're not from your civil engineering background, so you will not understand. So I'll discuss about only the velocity and drag force here. So how much wind velocity? So for that we just prepare a model that is a small scale. Like your if the vertical distance is, let us suppose this is 10 meter. So we are considering the scale is 1 is to 10, means 10 meter actual we are going to convert in the 1 meter of model, which is we measure actually in the laboratory level. So for the dimensional analysis or dimensional homogeneity or dimensional similarity, we have to maintain three things. One is geometric similarity, means the dimensions should be clear, that is should be your scale down. Then kinematic similarity, means the velocity at any point of the model flow must be proportional to a velocity at a corresponding point in the prototype flow. So this should be, another one is your dynamic similarity. So dynamic similarity is about your force. Remember please, dynamic similarity is achieved when the force in the model flow is scaled by constant factor to corresponding force in the prototype flow. So remember, in general here you can see very important point. In general, the flow field, in a general flow field, complete similarity between model and prototype is achieved only when there is geometric, kinematic and dynamic similarity. So all three should be, for complete similarity all three should be maintained. So you have the theorems, Buckingham Pi theorem for your dimensional analysis, and also you have the Rayleigh method. So I have given very well. I'll upload the PDF. You can go one by one. Sir has covered very well these things. So I'll just jump on the question answer session. So this is example from the book. Single symbol actually I am following. And this is your Rayleigh method. So okay. So now I'll discuss about question answer. Here is again the matching the list, the non-dimensional numbers. Match list 1 and list 2 and select the correct dimensions for the properties using the code given below. This is code list 1 and list 2, PQR and ABCD. Contain dimensionless parameter, list 2 contain the ratio. So Mach number, Reynolds number, Weber number and Froude number. Option A, ratio of inertial force to gravitational force. Option B, ratio of fluid velocity and velocity of sound. Ratio of inertial force to viscous elastic force. The ratio of inertial force to surface tension force. So this is about. So very easy one. I think your open channel flow is not covered yet. So just for your simplification, I want to just give you idea. The Froude number is the ratio of inertial force divided by gravitational force. So for S, your option A will be correct. Mach number is the ratio of elastic force, inertial force divided by elastic force. Then Weber number is the surface tension, inertial force divided by surface tension. So let me just correct. The Froude number is S going to goes with A, or here should be 1 2 3 should be there. 1 2 3 4, then you can match very easily. So your S is going with 1, S is going with 1, these 3, 1 is neglect, option D is neglected. Now your map number going with the 3, that is P is going with 3. Yes, these two may be correct. Now another Weber number is going with the this 4, that is R is going with 4, so R is going with 4. Yes, option A is correct. So like that you will approach the solution, not hurry. Okay, let us move on the next question, very important. Both Reynolds number and the Froude number assume significance in one of the following example. Means the 4 option is given, out of 4 options in any option, any one option, you have to, or you can apply the both one number, Reynolds number and the Froude number. Motion of submarine at large depth, motion of ship in the deep sea, this is motion of ship in the deep sea, cruising of a missile in air, flow over spillways. So you have 4 options. Just think on that, very very important question. So no and join is still okay. Okay, anyway I am recording the video, so anyone can access after uploading on the YouTube. Yes, so here answer is your front of eye, you can see, as your ship in the deep sea, your ship will move on the surface of the sea. So on the surface you can apply, that is the wave will be formed. Once the wave will be formed, so okay, I have the detailed solution here, so I want to just show you. Here you can see very clearly concept. So this is your Reynolds number, is the ratio of inertia force divided by viscous force. Froude number, the ratio of inertia force divided by gravitational force, as we have discussed already. So Reynolds number matters when the viscosity is important. Froude number is important when the free surface important, when the free surface wave are important or gravity are important. So both number are significant only when viscous and gravity effect coexist. Both number is important when the both things is exist, that is viscous effect as well as gravity effect. Okay, so happens when the body move at the free surface of the fluid, which happen, these things will happen when the body is move on the free surface. Just think on that. Here the body is moving on the free surface of the fluid, so this is the condition, because as you can see here, a ship move at a free surface of the sea, flow is influenced by viscous drag and wave making resistance. Hence both Reynolds number and the Froude number are significant. Think on that, because your fluid have some viscosity. Once your ship is moving in the forward direction, in this direction, what will happen? The viscosity of the fluid will affect on your seep motion, and also your the here you can see wave will create the resistance, which is this wave. So free surface also here, free surface effect is also here, so you can think of that. Okay, other options: motion of submarine at large depth. This was the first option, so let us discuss about this also. So submarine is deep underwater, so no free surface wave are formed. Only Reynolds number is important because viscous or inertia is acting on that. Fluid number is not relevant. Option C was cruising a missile in air. Motion in air, no free surface. Only Reynolds number and Mach number is relevant. Fluid number is irrelevant. Option C, flow over spillways. So free surface flow. So fluid number dominate. Use in hydraulic jam critical flow analysis. Reynolds number is usually very high in spillway, that is turbulent flow, so viscosity has negligible role. If the Reynolds number is very high, so the viscosity effect negligible, there is no meaning of the viscosity if the Reynolds number is very high. Why? As you can see here, the Reynolds number is the ratio of your inertia force divided by viscous force, that is force due to viscosity. If Reynolds number something your 40,000, if Reynolds number is 40,000 divided by I by V, that is I by V means here viscous force, I am going to write mu, right, remember. So your inertia force is 40,000 times of your viscous force. If something is 40,000 times of your viscous force, there is no meaning of the viscous force. If, let us assume, if you have something 40,000 mangoes and only one orange, so is there any meaning of orange? No meaning, only the mango. If someone asks what you have, you will tell we have the mango only, because you have only one orange, there is no meaning. So similarly you can understand these things. So now let us discuss about the question number 4. A dimensionless combination of pressure drop delta P, dynamic viscosity mu, and velocity V and length L is dimensionless combination. So how you will decide? You have the pressure drop means you can, because we are going to discuss about the dimensions, so there is no meaning of drop here. So pressure, you can assume the pressure, viscosity, velocity and length. So using these 4, which combination is possible? Whether del P by U square, del P by V square L, VL divided by mu, del P divided by mu VL, and another one del P by mu V. Which option is possible? So how you will proceed? So you can proceed with this approach. I have already written here. So you have the dimension of pressure is this ml minus 1 t minus 2. The dynamic viscosity is Newton second per meter square, this is, and another one lt minus 1 and length is L. So how you will arrange these things? So you will get the dimensionless things. if you will arrange these things like delta P into divided by mu your velocity L. So this L and this L will be cancelled out automatically, and this L and this L will be cancelled out. This combination minus 2 will be cancelled out. Yes, this will be the correct combination. Del P L divided by mu V. This one, option D, will be correct here. So like that you can proceed. Okay. So another question is question number 5. The number of pi parameters. The number of pi parameters need to express the function. You have these variables: area, velocity, time, dynamic viscosity, length. So using these five, 1, 2, 3, 4, 5, 5 variables, you have to tell up, you have to correct, you have to give the pi parameters. Means how many pi parameters will be exist if you have these 5 variables, whether 5, 4, 3 and 2, which should be correct. Very important questions. This type of question you can expect in the final exam or GATE exam also. The number of pi parameters need to be expressed, the function of this. Okay, so this should be solved using the Buckingham pi theorem concept. So in the Buckingham pi theorem, what should be the approach? Step by step I have written. So identify the variables. So you have the 5 variables. First is A, velocity, time, viscosity and length. So you have the 5 number of variables, right? So you have the fundamental dimension 3. Using this, you have the fundamental dimensions 3. Means you have M, you have L, you have T also. You have all 3. So what we need to do for the pi, for the calculation of pi, so number of pi is equal to, number of pi k is equal to your number of variables, which you have 5, minus number of fundamental dimensions. So how many you have the fundamental dimension here? M, L, T, all 3. So here you need to put 3. So 3 minus 2, 5 minus 3, you will get 2 answer. So 2 will be correct. Remember please how you will calculate. So first we need to try to find out the fundamental dimension in the given questions. In most of the cases, always these 3 exist. In most of the cases, not always. Remember, I am telling most of the cases. Question number 6. The dynamic similarity is said to exist between two fluids flow when at corresponding point there are geometric similarity and similarity of force involved, kinematic similarity and geometric similarity, interaction of inertia and viscous force, interaction between inertia and viscous and pressure force. So question is asking about the dynamic similarity. Dynamic similarity is said to exist between two fluids flow when at corresponding point there are geometric similarity and the similarity of force involved, because as I have told already in the some theoretical discussion, the dynamic similarity is linked with the force. So remember please, option A will be correct here. Now very important question. In model experiments, in model experiment with wear, so we have one wear. If the dimensions of the model wear is reduced by factor k, so you are reducing the dimension by factor k, the flow rate through the model wear is the following fraction of the flow rate through the prototype. Option A, k to the power 5 by 2, option B, k to the power 2, option C, 1, and option D, k to the power minus 2. So this is the question. Again I want to read the question. The flow rate through the model wear is the following, is this, whether it is 5, k to the power 5 by 2, k to the power square 1, or k to the power minus 2 fraction of the flow rate through the prototype. Meaning here, let us suppose is talking about the flow rate means q. You have the q of the prototype is equal to x time of q of model. So whether this x value is this much or this much, this much, this much, when the condition is given, if the dimension of the model of the wear are reduced by factor k, means initially you have the dimension suppose L, but after reducing, that is if R I am going to reduce, so going to reduce L by k, we have reduced, means divide by k, so we have reduced by the factor k. So what should be happening? So for this I have the analysis. So question is asking about discharge. Question is discussing about the flow rate, that is discharge. So generally in wear actually discharge is approximated like that. L is the characteristics length of the width of the wear, which is width of the wear, and H is the head of the water above the crest. The step 2, effect of scaling by factor k, means here you have the effect of scaling by factor k, means if the model is a geometrically similar scale model, then what will happen? Let us suppose you have the prototype like that, this much height, and in the model is this much. So if it is geometrically similar, then you can write your scale is, that is k is dimension, that is length dimension of prototype divided by length dimension of model. Means here length dimension of your prototype divided by length dimension of model. So after dividing you will get some factor here, that is whatever the factor. So that factor the question was asking about. So this was the node concept. So the factor meaning here is this, that is scale. You remember please, scale means the prototype divided by model ratio, growth ratio scale. Similarly, for height, you will get same thing. K is equal to hp by, that is the height of the prototype divided by height of the model. This same thing. So when you will go for discharge, so you can write like that. Discharge of model, so here you will put the model. Discharge of prototype. So LP and HP here, so you need to write whether LP in terms of LM or LM in terms of LP, similar for HM or HP. So we are interested in the solution. I have written the LP by K, that is LM in terms of LP. So LM here LP by K, HM here HP by K, power 3 by 2, similar, the similar thing. So LP will cancel out. So finally we will get this one. So QM, here is QM divided by QP. So your QP is, this is QP, K to the power 5 by 2 QM. So now you can compare here. QP is equal to this much, K to the power 5 by 2 QM. So X value is K to the power 5 by 2. So this was your final answer. Option A. Option A will be the correct answer. Remember this. So now let us move with the next question. Very important. Again, this is very important. So relationship, question 8, the relationship between the length scale ratio LR and velocity scale ratio VR in hydraulic model, in which the fluid dynamic similarity model is maintained. Here condition is given, remember please. The fluid dynamic similarity model is maintained means you have two numbers. Generally in fluid mechanics, in civil engineering, we use these two here, Reynolds number and fluid number. So Reynolds number is, and what is fluid number? The fluid number is nothing but V by G capital D. Similarly, for Reynolds number, V rho V L divided by mu. This is for Reynolds number, this is for your fluid number. Okay. So here question is asked, clearly telling the fluid dynamic similarity model is maintained. Means you have to maintain these two things. So first one is the fluid number for your model, that is F for model, and then the fluid number for your prototype. So means V by GD for your model and similar for your prototype, you will write here. Okay, so velocity ratio you have to find out, and the length ratio also. No, you have to find out the relation between these two. So the VR and LR means nothing but LR is your LP by, that is length of prototype divided by length of your model, and VR is prototype velocity divided by model velocity. So now you can think here. your. So what is G actually? G is meter per second. And what is D? D is the unit of, D is area by top width. So again you have meter. So this is under root meter, and meter per second square, and here you have meter. So means meter square. So once you will, this is meter square, so you can cancel out the root. So here you can write very easily Vm no, for the G actually we have, G is the your acceleration due to gravity, so this is your 9.81. So this is have the actually the values 9.81 meter per second square. So we will not consider. So remember please, such type of mistakes should not be do, should not done, because G you have the constant value 9.8. So will, this is constant, you can say this is constant. So for constant will not involve in the dimension analysis. So only m is remaining, root m means your, if this is model, Vm divided by root Lm Vp divided by root Lp. This is root Lp. So Vp by Vm, Vp by Vm means your Vr is equal to Lp should be this. So root Lp by Lm means Vr is have the relation under root Lr, like that. This is your final expression. So you can say option D is correct here. Vr is equal to root R. So this is your correct option. So the final, I think, yeah, not given. Okay, so remember please, such the analysis should be like that. You will not consider the G because it is a constant. Remember please, you can do mistake like that. So that's why I will be discussing. So again, the model analysis of the pipe flow are based on. So the pipe flow may be these two types. One is partially and another is completely full, completely filled. The water is completely filled. So we are discussing in this question this one, not this one. The model analysis of pipe flow are based on whether Reynolds number, Froude number, Mach number or Euler number. Which option should be correct? Remember please, the in the pipe flow, whether it will, pipe flow means here the pressurized flow, remember. So whether it is depend on your gravity or not. If the gravity is involved or free surface is involved, then we'll go with the Froude number. Otherwise, if the viscous is dominating, viscous force is dominating, we'll go with the Reynolds number. So in pipe flow, pressurized flow, always remember please, Reynolds number is dominating. Means once we will, when we will do the dynamic similarity in the for the pressurized flow, we will go with the Reynolds number, not the Froude number, Mach number, etc. The similar question, question number 10, the model analysis of aeroplane moving at supersonic speed is based on? So Reynolds number, Froude number, Mach number, or Euler number. So just think on that. Aeroplane, whether the Froude number is applicable, whether the Reynolds number, Euler number, Mach number. So generally, remember please, this for your kind information, the aeroplane will design based on the Mach number. So remember. Now another question number 11. So I am going to take break and I'll discuss after taking the 5-minute break. So please you just try to solve the question, pause the video, or you can solve the, or you can pause the video also. Okay, so I'm going to take 5 minutes. So okay, now we will discuss about the question number 11. uh, 1 is to 30 model of an Ogee spillway crest record an acceleration of 1.3 meter per second square at certain location. The homologous value of acceleration in the prototype in meter per second square. So you have one spillway like that, Ogee spillway. Okay, you have the Ogee spillway at some locations. Let us suppose here your acceleration value is in the model. This is model. You have 1.3 meter per second square. Okay, and you have the model and prototype ratio 1 is to 30. Means if your Ogee spillway is, that is 30 times bigger than your model. Remember, the homologous value means at a prototype in the prototype at the same location, what should be the acceleration? Acceleration in prototype you have to find out. So you know already what is acceleration, because we need to first we need to find out the relation between you have here the 1 is to 30 means you have the length scale LP by LM. 1 is to 30 means you have the length scale 1 is to 30. This is your LR. So you have to convert this acceleration in terms of length scale. So acceleration is nothing but the unit of acceleration is meter per second square. The unit is this. Okay, meter per second square. And you know already, or you can say the velocity, this is meter per second velocity, and time 1 by t. So your velocity ratio is what? Velocity is related with your length ratio is LR. Means your acceleration have velocity, the function of velocity, and your velocity is related with the LR, that is root LR. Means your acceleration is, when you will convert your acceleration in terms of length parameter, you will get LR. The meaning of this, AR is equal to LR. AR is AP divided by AM. LR means LP by LM, which is 1 by 30. So from here you can very easily calculate. AP is equal to AM is your 30. AM is your 1.3 into root over 1 by 30. So very easily we will get the final answer. Let me just show you. So here you will answer. I think I did somewhere mistake. Where is? Okay. similarity law. So LR is equal to LM by LP, 1 is to 30. Okay, and time scale ratio. Okay, so time scale ratio TR is equal to LR. How is it possible? How it is TR is ratio of a root LR? Velocity is your, no, the distance by time. Oh, let me just show you how it is. Distance by time. So you can write this time is equal to distance change in position divided by velocity. So your time means change in position means this is in meter, and this is your L, that is length dimension, and this your velocity is related with the root L. So LL, so your TR is equal to root LR. Okay, so from here you can think like that. So remember please, such type of mistake you should never do. Sometimes you can do such type of mistake, but remember T is how you will convert your time, that is time scale ratio with the T, because your acceleration have the function of two things. One is your meter, another is time, that is time square. So meter is directly you can write in the length because you have data in the length scale, but how you need to convert this time ratio in your length scale. So how you will convert? You will convert like that. You will link with the velocity, because why I am linking with the velocity, because I know already from the Froude number similarity the velocity is root L. The velocity ratio you can write root LR. That's why I am linking with this. So always remember, so acceleration will be the same. Always remember. So that is AR is equal to 1. Means LR, that is meter per second square. So T is related to LR. When you will do the square, root LR square. So LR will be cancelled out. You will get the final answer 1. So if it is 1, so there is no change. There is no change in acceleration from model to prototype. Remember. Okay. So now let us move with the next one. Question number 12. So you have to clear mind. You have to have the clear mind. This similarity, dynamic similarity. In the previous year gate questions, if you look the previous year gate question, lot of questions are there on from the dimensional analysis. You can expect in your final exam also, NPTEL final exam, gate exam, another exam also you can expect. Very important. This topic is very important from fluid mechanics. Also your pipe flow is also very important. And another one is the venturi meter, such kind of things also very important. Okay, still I am in the class, but no one joined still. Okay, I am recording. So question number 12 is a scale 1:50 scale model of spillway is to be tested in laboratory. Okay, the discharge in prototype is 1000 meter cube per second. the discharge to be maintained in the model test. So you have the scale of the model, means you have LR, means length scale 1 is to 50, and your question is discussing about the prototype. Discharge is given 1000 meter cube, meter cube per second, discharge to maintain in the model test. So here one thing is, remember please, what is, you have the value in this, that is the QP in the discharge, this meter cube per second. You need to convert these things your in the length parameter, because you have the one thing for the conversion from model discharge, prototype discharge to model discharge, only the length parameter. You have only the link with using the length parameter, you can convert prototype to model. So you have to have convert this your discharge in terms of length parameters. You have to convert. So how you will convert? Your discharge is nothing but area into velocity. So area is L square and velocity is root L. We have already established. And why root L I am writing? Because as per the Fruit law, as per the Fruit number. So your QR is equal to LR square, this is, so QP by QM is equal to L to the power, this is 2 and this is 2 plus half, 5 by 2, 5 by 2, LR 5 by 2. So from here you can calculate Q model is equal to 1000 divided by 1 is to 50 to the power 5 by 2. So your final answer should be, let me just calculate. So 1 is to 1 divided by 50 to the power 5 by 2.5 you can write. Okay, divided by 1000 1000 divided by, this is bracket. So you have to have very clear about your calculation. Sometimes in the fast mistake, 1 divided by 50, 2.02, so 1000 divided by 0.02 to the power 2.5. Oh, so yes, so your QR is equal to this much after the calculation, and your QM, when you will calculate the QM is QP into QR, so you will get the final answer 0.056. So similar thing here is done. QR is equal to L to the power LR by 5 by 2. One thing remember, so the unit of Q is meter cube per second. Meter cube means what? L3, and second is L2, we have already discussed. So L3 minus 1 by 2, so you will get again L to the power 5 by 2. So remember, you can calculate with this formula and using the unit also very easily. Okay, this is also very important question. The drag force F on a sphere kept in uniform flow field depend on the diameter of the sphere d, flow velocity v, fluid density rho, and the dynamic viscosity mu. Which of the following option represent the non-dimensional parameter which could be used to analyze the problem? So which of the following option represent the non-dimensional parameter? So you have what is drag force F, another uniform the uniform flow field depend on the diameter of the sphere, which is d sphere, and the flow velocity v, fluid density rho, dynamic viscosity mu. So which of the following represent the non-dimensional parameter? So using this, you have to write the non-dimensional parameter, which is you have to write the two non-dimensional parameter because option is given everywhere the two. So what should be the best possible? So using the Buckingham pi theorem, you can easily calculate, or you can guess. You can also guess. So you have to know already. You know actually from your the last classes, rho v d divided by mu. This is your Reynolds number. So this option is here, rho v d by mu. This option is here. This is also non-dimensional, but you cannot go with this. Because you have to make the non-dimensional numbers like that, which have some meaning, physical meaning. Okay, so Reynolds number. Okay, fine. Now these two option is remaining only. Force divided by rho v d square force divided by rho v square d square. So non-dimensional means what? The force unit should be equal to the dimension of rho v d square. So rho is kg per meter cube, v is meter per second, d is meter square. D is meter square. So this meter cube will be cancelled out. And kg by second, whether kg by second is the unit of force? No. Go with this force, that is rho is kg per meter cube, velocity square meter square per second square into d square meter square. So meter cube, this is meter square 1 meter, cancel out, only meter will remain here, and second square, this is yes Newton, kg into meter per second square. This is mass and this is acceleration. Yeah, this is Newton. So we can go with this. Option C will be correct. So like that you will approach such type of questions. Always remember, please. So option C will be correct. So here is the Buckingham pi theorem you can apply. So you have these three the fundamental units. Total variable you have 5 and 3 fundamental units. So you have to make 2 group. How much? Non-dimensional group you should make the 2, and 2 should be the, you can go with this, the analysis. Okay, so why 2? Because of this. The reason is your total number of variable divided minus repeating variable. So you will get this. So other question, very important. The water is flowing through a pipe of 30 centimeter diameter at a velocity of 4 meter per second. Okay. Find the velocity of oil flowing in another pipe of diameter 10 centimeter. Okay. If the condition of dynamic similarity is satisfied between two pipes, here the dynamic similarity is satisfied, the viscosity of water and oil is given 0.01 poise and 0.25 poise. Very important question. The specific gravity of oil is 0.8. Okay. So you have two pipe. One is this one. Which is 30 centimeter. Another is 10 centimeter. Okay. Here is water is flowing. The velocity is 4 meter per second. Here velocity you need to find out. This is oil and this is your H2O, water. Okay. Another data, yeah, dynamic similarity is satisfied between two pipes here. The viscosity of water is given 0.01 twice, and viscosity of oil is given 0.025 twice. The specific gravity of the oil is 0.8, and the specific gravity of water you know already 1. So 1000, the density of water is 1000 and density of oil is 800. So here one clue is given only, the dynamic similarity. The everything is different from case 1 to case 2. Diameter is different, the fluid flow is different, the flowing fluid is different. So only link is given between these two by the dynamic similarities. Okay, so how you will proceed with? So you know already, in pipe flow we will discuss about, or we'll go with the Reynolds number. Always know, we'll go with the Reynolds number. So dynamic similarity required equality of Reynolds number. For the dynamic similarity, that is force similarities, because Reynolds number is the ratio of force, inertia force divided by your viscous force. So the force similarity, for the dynamic similarity, you need to maintain the Reynolds number, these two. So let us equate the Reynolds number. Reynolds number of water, Reynolds number of oil. This is Reynolds number of water and Reynolds number of oil. So all data you have, row of water you have, row of oil you have, velocity of water you have need to find out the velocity of oil, velocity of water you have, diameter of water flowing pipe you have, diameter of oil flowing pipe you also have 10 centimeter. The dynamic similar, this is your kinematic viscosity, dynamic viscosity you have of water and poise. So very easily you can calculate. So one poise means, one poise is, let me just write, one poise is 1 by 10 Newton second per meter square. So 0.01 poise is, this is 1 is to 1 by 10. So 0.01 into 1 by 10. So finally you will get 0.001 Newton second per meter square. So this is similarly for oil and rest of the things you know already. Rest is only calculation. So here is 1000. This is velocity of water pipe, diameter of 30 centimeter, which is 0.3 meter, and this is in Newton second per meter square. Similarly for, you will put for 800, 10 centimeter, 0.00525, and the velocity of oil, finally you will get 37.5 meter per second. So this question is very, very important. You can expect this question in your final exam as well as your GATE exam, or other competitive exam also you can expect. Remember please, very important question, because only clue is given dynamic similarity, nothing else. If you not know the concept what is dynamic similarity, whether we'll use the Reynolds number, Froude number, such type of information required for solving this question. So such this question is required lot of that is you need the lot of analytical things, lot of actually the pre-understanding things, if you know, then you can solve, otherwise you cannot solve such type of questions. So very critical questions. The rest of the question you will find out in the previous year. I think this question is whether in the previous year or previous year gate exam I'm talking, whether it is there or not I don't know, but you can expect. Okay, so another question, the flow of glycerin kinematic viscosity is given 5 into 10 raised to minus 4 meter square per second in an open channel is to be modeled in laboratory flume using laboratory flume means in the lab one channel is formed. When we will make a channel, when we will construct a channel inside the laboratory, that channel known as flume. Remember please, so don't be confused. So open channel is to be modeled in laboratory flume using water. The kinematic viscosity is 10 raised to minus 6 meter square per second. As the fluid flowing, if the both gravity and viscosity are important, because the condition is given already, because generally in the open channel flow we consider gravity only, but here in the question already told the gravity and viscosity both are important. What should be the length scale, that is the ratio of prototype to model dimensions for maintaining the dynamic similarity? Very important question. You have to maintain here both similarities, that is both number, Froude number as well as gravity number. The flow of glycerin in an open channel is to model in laboratory flume using water. Remember, you are going to model in actual, what is happening, the flow of glycerin in open channel is to be modeled in laboratory flume using water. Means at the place of glycerin you are going to use water. Remember, at the place of glycerin you are going to use the water. In that case you have to told in this question, you have to solve the length scale LR, and the rest information is given. The gravity and viscosity are important for maintaining the dynamic similarity. Very important question. So how I will proceed? So kinematic viscosity you have. So Reynolds number is rho Vd divided by kinematic viscosity, dynamic viscosity. So you can write in the kinematic viscosity term Vd divided by kinematic viscosity. So because I have not pen today, so I'll just show you the answer and how I will proceed. So we need match both Froude number as well as Reynolds number, because in the question is given already. So the length scale is nothing that is prototype divided by model. So lambda here is considering at the place of LR, here lambda is given. Okay. From Froude number similarities, your velocity is equal to what? Root LP by LM. From the Reynolds number similarity, your velocity is, you can model here kinematic viscosity, because kinematic viscosity is given in the question. So kinematic viscosity of model, kinematic viscosity of prototype divided by model. And here Lm by Lp is what? Lm by Lp is 1 by lambda. From here you can consider. So equate the two expression for Vp by Vm. So from another Vp by Vm you have root lambda. From the Reynolds number similarity you have V mu P divided by mu means, I am talking about the kinematic viscosity, mu m 1 by lambda. So here the lambda q, lambda 3 by 2 and lambda is equal to this. Once you will put this value here, you will get final answer 63. But this question is very important. As you can see here, your Reynolds number I have just talked about. Let me just briefly discuss. Lp divided by mu P is equal to Vm Lm divided by Lp Vm. So you have considered Lp by Lm is lambda, and in the Froude number similarity you know also, first you will look, okay, let me just write GD or okay ZD. I'll write here length, I'll write direct, because there is no meaning of ZD when we are doing such kind of things. So from here V is L, root L, and so from here we will consider these things. Lambda is equal to Lp by Lm. So in the Froude number, why we are focusing on velocity? Because in the both terms, both numbers, the velocity is exists. So we can write the velocity term in terms of your length scale. Also here in your Reynolds number you can write the velocity in terms of length scale, and another, the dynamic viscosity, kinematic viscosity is already given. So remember here, whatever we have assumed, the lambda is Lp by Lm, so that things we have put here. And this was your equation 1 from the Froude number. This was your equation 2 from your, this was your equation 2 Vp by Vm, and then equate, and then after you will get the answer. This question here is written only the 3-4 step, but this question is very important. So if you have not familiar with such type of question, please, you need to solve this question 2 to 3 times. This question and this question you need to solve 2 to 3 times. Once you just look and then go through the solutions, then after you will try to solve without looking the solutions, or you can utilize your brain also, how you will proceed with the different way. Okay, the next question is, the Euler number En is written as, the Euler number you can write whether V by root k by rho. Option B, rho V square L by sigma. Option C, V rho divided by delta P. Option D, V by root delta P by P. Which option should be correct? Okay, without delay I'll go through the answer. So definition of the Euler number is what? The Euler number is the ratio of pressure force to wrong inertia force by pressure force. Okay, whatever. This definition is wrong. Okay, don't worry. So we'll not go with this. So finally, your answer should be the Euler number delta P divided by rho V square. So not any option, but so you can write like that also, V by delta P by rho. V by delta P by rho. Oh, this is I think rho. Yeah, this is rho, not P. This is rho. So option D will be correct. So you can go with your interpretation also, not whatever I am writing here. So this should be made mistake sometimes. The human error, the calculation here, the things, the remember please. So you have to go with your also with your brain. Okay, so dynamic similarity exists when the model and prototype have the same. Okay, we have just solved these questions already in the previous. Length scale ratio and time scale ratio. Length scale ratio and the velocity scale. Length, time and the velocity. Length scale ratio, velocity scale ratio and the force scale ratio. This is correct. So dynamic similarity exists. Another question. Assuming the thrust T means force, thrust T of a propeller depend on diameter D, speed of advance V, angular velocity omega, dynamic viscosity mu, density rho, which of the following dimensionless parameter can be derived by dimensional analysis? So you have the 4, means whether you will drive this 3 only, this 1 2 3 only, the 3 2 1 only. So a lot of combination here, the 4 combination is given, means any one, because in each option you have 3. So anyone cannot be derived, means anyone cannot be dimensionless. Whatever the option is given, any one of these 4 not have the 0 dimension. That is a dimensionless. So rho Vd by mu, this is correct. So here what we need to do, we need to check the dimensions. So already I have written. This is your dimensionless. This is not dimensionless. Vd mu by rho, this is not dimensionless. If second one is not dimensionless, so this will be cancelled out, only this will be correct. Option C will be correct, because 2 2 2 is everywhere. Next question. A dimensionless combination of pressure drop delta P, dynamic viscosity mu, velocity V and length L is what? So again here same thing, we need to check the dimension. So when you will check the dimension, you will find out option 4 The option C will be correct, that is del P L by mu, del P L mu V. This would be correct. You can check also the calculation part. Okay, so next question, if the same fluid is used both in the model and prototype, you are going to use the same fluid, water in model and water in prototype also. If it is desired to have equal Reynolds number and the fluid number in the model and prototype, the scale of the model is, remember please, if the desired, if it is desired to have equal Reynolds number and fluid number, so means if your model have, if your prototype had Reynolds number 5000, then your model also have the same value 5000. If your prototype have fluid number is 1, or let us say 0.5, then fluid number of your model should also be 0.5. These two combination is given, these two condition is given here. So the scale model is asking LR. So you have to remember these two things. So you know already the same thing here you need to do. This is your Reynolds number similarity, so Vm by Vp is Lp by Lm, and in case of fluid number similarity, your Vp by Vm is this root Lr. So combine both conditions. For Reynolds number, Lr is equal to 1 by Vr. Here you can consider this is Vr, and for fluid number, Lr is equal to Vr square. You can write like that. Now they equate these two things. So once you will equate, what you will find out? You will find out Vr is V cube is equal to 1. So Vr is equal to, you have 3 root 1 1 1. So finally you will get Lr is equal to 1. So length scale, that is model and prototype should be equal. Lr is equal to 1 means what? If Lr is equal to 1, it means what? Lp by Lm is equal to 1. So Lp is equal to Lm. Very easy. Next question. So this is last question for today. A Harvard model has a horizontal scale 1:150 and the vertical scale is 1:75. The interval between successive daily high tide in the model will be nearly. Okay, so a model you have 1:, horizontal scale 1:150 and vertical 1:75. So the interval between successive daily high tide in the model will be nearly. So how you will proceed with that? So time scale in the distorted model you know already, Lp by Lm. So root L, it is Tr is equal to root Lr. We have already seen in the previous questions. So here you can see for the free surface flow, the characteristics length in the vertical scale is this. Tm by dv 1:75 you can write. So calculate. So you will get the Tm is equal to already 7. The question is given something. prototype tide interval is 7:45 minutes, somewhere it is. No. Okay, question I think is incomplete, so you can go with the final answer. That is the this is the solution part is given already. So interval between the successive daily tide in the prototype is 12 hour 25 second. So how much in the model? Okay. So data is missing in the question. So you can go with the solution part. So finally you will get 86 minutes. Remember. The next question is same. A model tested is to be calculated in water tunnel using 1 is to 20 of a submarine which is used to travel at a speed 12 km per hour deep under the sea. The water temperature is in the tunnel is so maintained, the kinematic viscosity is half of the sea water. Okay, that its kinematic viscosity half of the sea water. At what speed is the model test to be conducted? So the explanation here is very very clearly given. So you can go with this. Another question. Okay. So another question is your river about the flood number similarities. A river model of horizontal scale is 1 is to 250 and vertical scale 25, 1 is to 25. Estimate the model value corresponding to prototype slope is given. If the model velocity and discharge is given already, estimate the corresponding prototype velocity and discharge. So you know already your velocity is root LR and your discharge is root L to the power 5, LR to the power 5 by 2, that is 2.5, and slope you can calculate like that. So everything is here. You wish you go with one by one, step by step, you will very easily. The model slope means what? This is your model and this is your prototype. So you know already that is Z means vertical and horizontal scale. So with this you can calculate very easily. So okay, thank you for today. So no one joined till now. Okay, I'll upload the video. You can go. Anyone can see. Okay, thank you.